Okay, section 5.1, part 2. We're going to do some work continuing to estimate with finite sums. So we did some work in class the other day using area and rectangles and even a volume of a swimming pool. So now we're going to talk about estimating the volume of a sphere. So let's say we have a sphere that has a radius of 4, and we're going to center it on the x-axis, the x and y-axis. So it's going to look like this, and it's a sphere, so it's a three-dimensional ball. And the equation for the circle is x squared plus y squared equals 16. Now, each one of these slices, and again, I'm going to use rectangular approximations, each one of these slices that I make is actually a very narrow cylinder. I've turned it from here on its side, where this part of the slice corresponds with the width of each slice. We call that our dx. This part corresponds with the radius. Well, hold on. Oh, where's my eraser? Let me try it this way. Okay, so this is my radius, and the radius is actually my function value f of x. So each one of these slices follows the formula for the area of a cylinder, which is pi r squared h. In this case, pi is a constant. H, the height of my cylinder, which matches over here, is my dx. That is also a constant. And I'm going to have a whole bunch of little radiuses depending upon how many slices I take, and each of those is going to be f of x. I've got to write this as y in terms of x then. So y squared equals 16 minus x squared, and y equals 16 minus x squared, take the square root. But since I want r squared, I'm going to actually call this function just my y squared, which is 16 minus x squared. So let's set this up for our interval. Let's take a look at this. Here's a little better picture. So we're going to divide it into 8 subintervals, but I'm going to use a little trick here. I'm just going to use 0 to 4 because this is symmetrical, and I'm going to multiply it by 2. So each subinterval is, or each dx is 1, and I'm going to use the midram. So my values that I'm going to evaluate at are going to be 1/2, 3/2, 5/2, and 7/2 with a dx of 1. So let's set this up. Remember, I'm getting the volumes of all these little cylinders added together. So it's going to be my pi r squared h. We already said that h is my dx, so in this case, 1. I'm going to use r squared, so each one of these is going to be the function evaluated at 16 minus x squared. So I'm going to do f of 1/2 plus f of 3/2 plus f of 5/2 plus f of 7/2. And I'm going to do 2 of those because remember, instead of going from -4 to 4, I'm just going from 0 to 4 and then doubling it. So that's what I need. So using a calculator, I'm going to get 2 pi times 15.75 plus 13.75 plus 9.75 plus 3.75, All of these are just found by plugging my x value into this function. So I have 2 pi times 43, which is 86 pi, or approximately 260.75219. So that's my area of a sphere, found by using slices and approximation. Okay, let's see what else we can do here. Let's do one other. Estimate the volume of a solid of rotation. So we're going to take the curve y equals 4 minus x squared, y-intercept of 4. It's an upside-down parabola, goes from -2 to 2. And I'm going to rotate this around the x-axis from 0 to 2. So I don't actually want this part of the function. So I'm just going to use from here from 0 to 2. And when I say rotate it, that means I'm going to take this whole circle. I'll show you this a little better in class too. But I'm going to take it and spin it around until I get a solid. Again, each one of these little curved pieces, my dx's, I want 4 subintervals with mid-ram to approximate the area. So I'm going to do just this part of my picture. I'm just going from 0 to 2. So each subinterval will be 1/2. So now my dx is 1/2. Again, these are little cylinders that I'm going to turn on their sides. So the height is 1/2. The radius is the distance from here to here, which in this case is 4 minus x squared. Okay, and that's going to be my radius. And I need my radius squared because I'm going to do pi r squared h again. Okay, I'm going to get a new screen. So pi r squared h, I'm going to add up a whole bunch of those. Pi is a constant, h is my 1/2, and I want my function, or my radius, squared. 4 minus x squared squared. And I've got to add up a whole bunch of those to get my area. So let's look at my midpoints again. 0, 1, 2. I need to use 1/2 and 3/2 for my subintervals. So my midpoints are going to be 1/4, 3/4, 5/4, and 7/4. So pi times 1/2 times my function 4 minus 1/4 squared squared, 4 minus 3/4 squared squared, 4 minus 5/4 squared squared, and 4 minus 7/4 squared squared. So again, pi over 2, pi times 1/2, times 15.504 plus 11.816 plus 5.9414 plus 0.87891. Adding all that together, I get pi over 2 times 34.14031, which is approximately 53.627,473.54. Might as well write them all down for now. So that's it. We'll do a couple more of these in class, but this is the idea now of starting to get some volumes using little slabs of area rather than just surface area. And that's it.